I'm very excited to be here with you today. So as anticipated, I will not discuss today anything about the dark matter because essentially I believe that Clea, Rita, Azam has pretty much covered all that I could possibly say. Most of it I would say. We've been working together since a while now. So let me just now focus the attention on who we are. You have heard a few stories already today. Before going there, just a few more words about myself. I believe that I was already pretty much introduced. So, as mentioned, I come from Italy, and specifically from an island, Sardinia. I was born and raised essentially in Cagliari on the coast. I did my PhD there. During my PhD, I joined both the DEAP 3600 and DarkSide 20K experiment that were mentioned by Clea and Rita. During the pandemic, I have done my very first postdoc there. That was my first time having hands-on experience in a lab. And that's actually when I connected with Dr. Azam here. I worked together to the PAT scanner project, essentially a medical application of the DarkSide 20K dark matter research. Then in 2023, I moved to California. I packed a 20 kilos suitcase and an orange cat to cross the ocean and most of the North American continent. In Riverside, I joined a crew of enthusiastic undergraduate students, graduated students, most of them working again on the dark matter detection in a liquid argon detectors, so DarkSide 20K mostly. It was an amazing time. I could use the hands-on experience that I already gained in Italy while developing more skills also related to mentoring, professional development, R&D. And I believe that there I gained a deeper understanding of the kind of research group that I would like to build myself. That's something that I could finally start doing when I was hired to Queen's University last August. And that's me with my companion just after crossing the border and getting my work permit in Toronto, Canada. So as anticipated, let's have a look to who is doing physics and science specifically today. So the very first step along the research career is essentially applying first and entering the PhD schools. That's whenever you essentially learn how to do research. So these are the numbers, the statistics in a percentage of women who applied and entered the PhD schools in a few years ago, as published in this very nice survey. She figures. So this is about Europe. You can find similar numbers and statistics for any country within Europe or outside, according to what interests you most. And this is divided by disciplines. So the very first four lines here are the disciplines essentially related to anything like education, arts and humanities, social sciences, business, law, administration, journalism. Here we see that on average, about 50% of the PhD students are women, which pretty much makes sense. There is no reason why it shouldn't be like that. And kind of the same is observed then in agriculture, health and welfare, services, veterinary. So here we notice that the probability for any supervisor to hire a PhD student who identify themselves as a woman is essentially the same as them being men. If we look to large enough pool of PhD students, more or less we will see that the number of male or female will be essentially comparable, the same in these disciplines. But when then we do the same exercise to disciplines like natural sciences, physics, mathematics, statistics, engineering, anything which is about hands-on technology, construction, we see that on average, the percentage of women among the PhD student population is reduced down to a percentage of about 30% on average. And this is again an average across all Europe. Probably you will find even worse numbers according to the specific country. If anyone is interested, I really invite you to have a look at the statistics for your country specifically, whatever you are mostly interested to according to your disciplines. So that's something that we should keep in mind. So apparently, that's why we talk about women in STEM. That's actually one reason why we are here today, not the only reason. Women, since the very first step of the research career, are underrepresented groups. We have less women than men. Since the very first step that eventually will bring them to be essentially a full-time scientist, which will be in academia, a lab, even industry, we can do science. So but then let's have a look at what happens when these women try to get funded. So at some moment after the PhD, usually you do at least one postdoc in the meantime, and you try to develop more leadership skills, develop your own ideas, and at some moment you try to get funded, to get research money if you want, to apply and essentially develop these ideas. One of the most competitive worldwide grants, opportunities to get funded is the European Research Council grants, and specifically the starting grant is the one dedicated to early career researchers. So eventually you do your PhD, and after a couple of years, you will try to get such a grant. When we look at the fractions of applicants, on average, we notice that more or less only 40% of the applicants are women, and the rest would be men. And we are not really surprised now, right? We noticed that already from the PhD step. But then, let's now look at how many of these women that have applied were also successful. And that's when we observe something very interesting. I was also happily surprised when I saw these numbers here. So more or less here the numbers, so we had about 1,400 more or less applicants in 2024. More or less you have about 600 women and 800 men. When then we look at how many proposals specifically in physical science and engineering were funded, it was about 209 for men and women, 73 proposals submitted by women got funded, or against 136 from men. So when we look at the probability of an application to be actually funded, when there is a woman who is applying, we notice that the success rate is essentially the same as men. It's about 13% compared to about 15%. So what these numbers are telling us here is that it is true that women are less than men when they are applying, but then they pretty much perform as them. The success rate is really comparable, which means that eventually, the moment that we look at high risk, high gain ideas, women as underrepresented groups, even if they are less in terms of how many applicants we have, they still thrive. And essentially, we are getting closer to a gender equity, at least in Europe, at least in the ERC. So we may wonder how so. How are we getting there? What are the factors that eventually are helping us get into a gender equity situation, which would be the ideal one. So we know that women are underrepresented groups. We saw that science, the very PhD, and eventually, essentially, if we look at the path that the single woman faced during the academia, it feels really like an obstacle race. So if the professional development is like climbing stairs, the step sizes for women seems to be somehow higher, so more challenging compared to men. But still, the results from the ERC starting grant for us are a first hint that whatever we are doing there, and I can discuss there in a second, it's actually working. Eventually, we're getting closer to unequal sex rates between women and men. So all the efforts that we are doing, so trying to have blind reviews where people don't look at who is applying, which means also their nationality, whether they're women or men, whether they are older than usually applicants, which also would reflect in career breaks. All of these elements, these abilities, these are things that usually people set in the very first page of the CV. So now we are trying to perform reviews where we don't really look at the very first page. This is a very first step. Our committees now are more gender balanced, and not really surprisingly, even if the review is still blind, we are noticing that again, we are getting closer on gender equity whenever we talk about fundings, even if women are still less than men when they actually start. But then the question would be, okay, so apparently, taking into account that the women do face more challenges than men during their career path, is working. So this is the right path. But exactly what are these challenges today? That's a good question. Why we are still seeing in 2026 that women are less than men when they are, at least when they are getting out of their PhD, they are applying for fundings for postdoctoral positions, professor positions. Why there are less women than men in STEM? We are not in the 1960s. This is not a story of Vera Rubin. Most of the cases, we do have the same opportunities in terms of education, presentations in conferences, connections, mentoring. We have the same supervisors, and most of the cases, really, there is no risk of like harassments or microaggressions at work. We are not there anymore. We were there just a few decades ago, so eventually, and there are still some cases, but this is not the norm. But still, we are seeing this underrepresentation. So what's going on? And well, I don't have the ambition today to answer this question. This is a really tough one. More and more people are trying to understand what's going on there, what are the challenges that still we have to address, and it should be taken into account whenever we perform any competition, which could be even when you are hiring the PhD student. There is actually a full discussion on how to make our PhD selection more equitable. So let's now connect again to the stories that we heard today. So I believe that from our student today, you have, of course, recognized the passion in math, in physics, astronomy, astrophysics, that pretty much was, at least also for me, a driving force. The curiosity, the passion eventually bring these people, and specifically women in STEM, to even apply at the university and perform physics or any kind of science. But then when they look around in the coffee lunch, in the classroom, their colleagues, the professors, they don't really see a lot of women there. And the more that we go into engineering and hands-on, this becomes even worse and worse. So the question, depending on your personality specifically, would be, okay, how come that there is no one like me here? And here today we are discussing only women in science. You can literally do the same exercise for any underrepresented group, which could be people with disabilities, ethnicity, socioeconomical background, up to you, whatever the parameter that you want to look at. Depending on the kind of the mentoring that they receive, specifically during the PhD school, which is, as we have said, where we'll learn how to do research. If there is not an adequate mentoring which kind of balances these kind of questions, the natural question would be, do I belong? So the student, especially a PhD student or an early careers researcher, will then wonder, okay, there are no people like me, women in science, do I even belong to this field? So should I just change? And if, again, depending on the personality, depending on the, essentially, all the nuisances in this that they face along their career, this will bring eventually them to some postdoc or even a permanent position. So to get there, though, you need to know that you need to have support letters from who have worked with you. And again, if you were using your energy, wondering whether you could belong in that field, probably you were not really outperforming. So this eventually brings to weaker references letter, which eventually will also determine that for you will be harder to be hired. There is much more just underneath the surface here. I'm just trying to give you the most outstanding and easy to see challenges that women in STEM and as underrepresented groups are facing today. All of this now piles up to the time where they have to apply. When they have to apply, all of these, let's say, challenges will reflect in a hard time in getting research grants, getting their ideas funded. And that's also why it is usually, at least in my personal perception, I have not seen a lot of women in STEM being also leader in their field, internationally wise. For some reason, which is essentially a reflection of all of these factors here, they are being hardly seen as a leader up to now. And again, there is also unconscious bias here, imposter syndrome. Women eventually overlooked as invited speakers, prizes. So I believe that this is a nice representation of the challenges, that in most of the cases, of course, there are still bad jokes, microaggressions are there, harassment. I'm not even going there. They are there. We should acknowledge that. And whenever this happens, it's very rare for a woman to actually continue in the career and in STEM. Most of the cases, this is the mountain hill that they have to climb. So all the work which is related to equity, diversity, and inclusion is exactly trying to help women in STEM climbing this mountain here. Equity is essentially the effort of treating people of all identities and background fairly and taking into account the opportunities and challenges that they actually have, which is a tough exercise, not really simple. we are not all equal, but we should have equitable opportunities. We wanted to embrace differences because essentially that's what allows us to actually perform physics or science in more in general, which goes beyond what we actually already know, which will be research, because we do need all of this multiple perspective. But in order to do that, we do need to create an environment which will be inclusive, which will welcome all of these perspectives. And hopefully we won't have at some moment students wondering whether they do belong or not, just for their gender or any other nuisance, which has nothing to do with the passion and the curiosity that is really the main requirement in this field. Today, we are trying to help with one of the small hill in this mountain here, which we will be trying to give more role models. So we here have today PhD student, postdocs. I happen to be the prof, which will be an example of women in STEM for across their the main steps, I would say, in their academic career. And we are just trying, and this, I believe that events like today is exactly what we need to climb together this hill. And as anticipated, we do have all the reasons to do that. And specifically, we work mainly on the dark matter detection. Specifically, that's what I mainly focus on. And the reason why I'm so interested in this kind of I will say, actually, this is just right, but the moment that we embrace a diverse environment, that's when we get a multiple perspective. As Rita mentioned, we don't know how dark matter looks like. Could be any of these animals that she showed us. So this representation here, this is from an artist, Troika. This is a very absorbent material, so much that essentially we lose the perception of its shape. Whenever it's in a room like this one, we need to embrace all the possible perspectives, just walking around it to really grasp its shape. That's dark matter. That's what we need to do in order to finally address this huge question. We don't know how it looks like. We need to think out of the box. We need a multiple perspective in order to eventually get its full shape, I would say. And that's all from my side.